So this equation has given us a graph already. Usually when they give us the graph, that makes things easier. We got the graph of y equals f of x. We need to sketch the graph of negative 1/4 f of x. So this is given to us in function notation because the function f of x is written in the image as well. The negative 1/4 is outside of that function. That means it's affecting the y. So this tells us all we have to do is multiply our y values by negative 1/4. If we take some key points on our original graph, 0, 0 is a key point on our original graph. And if you multiply your y by negative 1/4, you will still get 0, 0 when you do that. If we take another point on our graph, okay, I'm going to choose 4, 4. I could have chosen 2, 2 or 1, 1, but I'm thinking ahead. I already know I'm going to be multiplying my y coordinate by 1/4, so I'm looking for numbers that divide nicely by 4. So when I take 4, 4 and do the same transformation, I'm not going to rewrite y by negative 1/4 over and over again because it's obvious from the first one that I'm going to do that same thing to each of the points. I get 4, negative 1. That was one point on one side of my graph. I could take a point on the other side of my graph as well. Negative 4, 4. Do the same transformation, and I would get negative 4, negative 1. What's going to cause you problems in this unit is there's lots of little mental math things that you need to do. And there's lots of times you might just make a little mistake with a negative. So you have to be careful with that. One thing we're going to do, now I'm going to graph all of these new points. 0, 0, 4, negative 1. Oops, actually I have to move that up because the scale negative 1 would be halfway in between there. And negative 4, negative 1. Those would be my points. Shape stays the same, but there's my new graph. Mentally, when you see the negative 1/4, what you're going to want to think, here's our original, this negative reflects over the x-axis, and this will be a vertical compression by a factor of 1/4. So just as an overall visual, has our graph been flipped over the x-axis, our blue one? Has it been squished, compressed towards the x-axis? Yes. So we know that, you know, pending mistakes in our points, we got the basic idea here right. So that's a thing you're going to use to check. You're going to have a basic idea of what it should look like, and you're also going to do this method of looking at specific points so that you can see where should those specific points be when I graph it. Now this question asked us for the domain and range of each function. So I'll do the domain and range of the red one, the domain and range of the blue one. Again, we're going to assume, since it hits the end of the graph, negative infinity to infinity, and that doesn't change when we flip it over. We still have every single x value possible. For our range, we don't have every single range value. When we look at what is the smallest y value that we have, we see that the smallest y value is 0, and then it goes up forever. So in set notation, we would say that y is bigger than or equal to 0. In interval notation, 0 to infinity. And on the blue graph, now y is less than or equal to 0, or it goes from negative infinity up to 0. Now, we were given the graph to begin with. Do you recognize the graph? What graph is the red one to begin with? The absolute value of x. That was one of our parent graphs. So what I need you to recognize is this question could be asked like this, where they give you a graph and have it in function notation. You could have also been asked this exact same question if it would have, the wording would have been graph y equals -1/4 absolute value of x. That's the exact same question. What the black question there wouldn't have is they wouldn't give you the red graph. They would say you need to recognize from this that the absolute value of x is in there, and you know what that graph looks like to begin with. And then you would sketch the red graph on your own. And now that I have the red graph and some points on there, I could do these transformations and graph the same thing. So it's important to see that there's sort of two main ways that they can ask you questions. The easier ways are when you get the graph, because that sort of saves you one step. But if you're not given the graph, you need to recognize that the parent graph here is the absolute value of x. Draw that first, and then apply the transformations to it. Okay, questions you can do for number 1, or just question 3.